In the last class, we did a circuit lab where we lit up a light bulb. Today, we're going to talk about simple circuits and circuits where the resistors are in series. So, what is a resistor? You know what a wire is, you know what the battery is. A resistor is simply a wire that's thinner. And actually, a good example is a light bulb. So, last class, we had a light bulb that looks like this, had this, and then here we had the filament. And this is the wire that's really thin. And what it does is it resists the flow of electricity. So let's say that's a wire, and somewhere later it's kind of like thinner, a thinner wire. If there are electrons that are trying to flow through the wire, there's more we call it resistance that they're trying to get through here, and they are seemingly, or they're slowed down basically. So that's what a resistor is. You can think of a light bulb, or sometimes it's literally just a thin wire. It's like a component that's just a thin wire. Well, today we're going to be talking about voltage, current, resistance, and power. And these are the relationships between it. So delta V is equal to I times R. Voltage is equal to current times resistance. Power is equal to current times the potential difference, the voltage. So let's just jump right into an example. Um, and I'll explain this as kind of as we go along. Here's a circuit. This is a circuit diagram. So we don't actually draw a light bulb, or we don't actually draw a battery the way that they look, something like that. No, what we have are these components. Batteries look like this, a resistor looks like that, and wires are just lines. And this is what we call a simple circuit. That means it has one battery, it has one resistor, and it has wires. Okay, and they're connected as such. This longer part right here, this is the positive side of the battery, this is the negative side. It's not too important to know that, but I thought I'd just point it out. Well, let's see what we have here. The voltage supplied by the battery is 32 volts. We write 32, and um, the unit for volts, or I'm sorry, the symbol for volts is capital V. And we draw it like this, and so you should too. Just draw a V and put like little lines on the top of the V. That distinguishes it from V, voltage. This is V volts. Yeah, I know it's confusing. So we know what the voltage is for this simple circuit. We don't know the current. We know the resistance though is 20 ohms. Okay, that's omega. 20. Excuse me. So we can use our equations. Delta V is equal to I times R. Now, if I rearrange this equation, current is equal to delta V over R. And another equation we can have is R is equal to delta V over I. So those are good to have, although they're all derived from that equation. They're all the same equation, really. And so I is just V over R. So 32 divided by 20, which is, let's see, 1.6. And power is I times delta V. So we multiply these two numbers. That's 32 times 1.6. That's 51.2. And power is watts. So what do all these numbers mean? Okay, the current is what's flowing in the wires. We can draw it like that. We can say I is equal to 1.6 amps. And the current flows the same all throughout. So everything here is getting 1.6 amps of current. as the electricity flows through. Voltage is what's supplied by the battery. Um, in the circuit picks up 32 volts as it crosses the battery, and it will drop 32 volts as it crosses a resistor. But however you want to say it, this voltage is 32. The total resistance of this circuit is 20. And the power, you can think of it as the power supplied or the power dissipated by the resistor. This is a light bulb. It's like the heat given off of the light bulb is 51.2 watts. That's 51.2 joules per second. Okay. If the voltage increases, the current increases. That should make sense. If you increase the voltage of the battery, the current will go up. If the resistance increases, the current should decrease. If the voltage increases, what happens to the power? That should go up. And if the resistance increases, let's see, I almost forgot this one. We can say the resistance increases. We can say that I is equal to V over R, and delta V was here, so power is also equal to V squared over R. Excuse me. Yeah, power goes down. Wait a second. Yeah, it should go down. Yeah, current goes down, and so okay, just making sure. Sorry about that. Now, let's take it up. Let's crank it up a notch. What if we put two resistors in a circuit? Does that increase the resistance or decrease the resistance? And I have a useful analogy here. A resistor decreases the flow of current, and I like to use the analogy of you're driving down the highway and you have to go into you go from 3 lanes to 1 lane. It's going to slow down traffic. And then imagine you have to go from 3 lanes to 1 lane, and then down the line you have another 1 lane, it slows down for over and over and over again. Like you have these little booths. Maybe it's a toll road or something. Okay. Yeah, the more resistors you add, the more the resistance is going to increase on the circuit. And so it's going to slow down the current even more. So a series circuit are devices. The devices on the circuit are connected one after another with only one path for the current to flow. And okay, we have some equations there, but I'm going to show you just how to use them. What we have here is a circuit with resistors in series. Here are our equations. And what we have here are values that are occurring at these resistors. So it's dropping that many volts. That's the current flowing through that resistor. That's the resistance of that resistor. That's the power dissipated by that resistor, and so on. And, same thing goes for this one. To solve these, what we do is we simplify it. We can imagine that these two resistors kind of behave as one big resistor. Hopefully that concept makes sense. And that's actually really easy to do. What is the resistance now of this combined resistor? Well, you just add them up. We'll say that R1, I'll write it down here, R12, which is our combined resistor, it's not R12. R12 is basically just R1 plus R2, which is 5 plus 3 which is 8 ohms. And so this hypothetical circuit that we're building, the resistor 1, 2 has 8 ohms of resistance. Now the battery is the same, that's 24 volts. And we can find I, we just divide these, 24 divided by 8 is 3 amps. And power is I times V, so 3 times 24, that's 72 watts. Now, we figured out everything we can know about this hypothetical circuit, but let's go back to our real circuit. There is one number that will transfer over into these. It's not voltage, because the circuit picks up 24 volts and it needs to drop a total of 24 volts. So each one is not 24 volts. And the answer is current. So I1 is equal to I2 is equal to I12. And that's shown up here. And that's how we figured out R. So we're just going to bring in here 3 amps and 3 amps. And we'll just clean up the numbers here. So V is equal to I times R. So 3 times 3, that's 9. And 5 times 3, that's 15 volts. Power is I times V, so 15 times 3 is 45 watts. And 9 times 3 is 27 watts. Cool. So this resistor all by itself is dropping 15 volts of voltage. Resistor 2 is dropping the 9 volts. Together they add up to make 24. They both have 3 amps of current running through it. And this is how much heat or how much power is dissipated by each resistor. Cool, and I think that's actually it.